Hello students, this is a Digital Knowledge Irshad Academy with a video of operational amplifier represented as black box. Before going to circuit explanation, subscribe my channel and press bell icon so that the fresh video reaches you routinely. Looking at the circuit layout already discussed is a figure 4. Now we make a few assumptions. Z11 was here, that is renamed as Zi input impedance. There was a Z21 that will be called as ZO output impedance of black box, and of course this is gain and is a gain of black box. These are the foremost information about black box, and black box is defined in terms of Zi, ZO and A. These are the three parameters that must be known. These cannot be measured. These information should be given in the data book. Now coming to figure 5, almost same, and see that Zi, ZO have been renamed. Now let us go and calculate the equations. V1 is equal to current flowing through the circuit drops a voltage, and by will be called as I1 into Zi. V2 is equal to I2 flowing into ZL. When the current flows through the circuit, there is a voltage here that will be called as V0 or V output. I1 is equal to V1 divided by this by Ohm's law, V1 divided by Zi. I2 here will be equal to V2 or V0. V2 and V0 is the same, V0 divided by ZL. I1 can further be written as Vs divided by, why? Because this voltage is across these two resistors and forming a voltage divider network, and will be called as Zi plus Zs. This is the value of I1, and the value of I2 will be equal to a V1, that is output control generator, this divided by this plus this will be ZO plus ZL. Now this is the value of I1, this is the value of I2, and this, I put the value of I1 here, and it becomes here V1 is equal to Vs over Zi plus Zs into Zi, and V0 can be written as AVI, AV1 divided by ZO plus ZL. This is the value of current multiplied by impedance becomes voltage. This is equation 1. This is equation 2. Now output voltage can be maximum. We can increase output voltage if we use a large value of ZL. Of course, when the ZL is large, it's going to develop more voltage. Or keep ZO minimum, then it will drop a less voltage and most of the output voltage appear in the output. So for example, there are 10 volts here, 2 volts are dropped across ZO, we get 8 volts in the output. But if the ZO is minimum, all the 10 volts will appear across ZL, we get maximum voltage in the output. Or increase V1, or can be increased by gain. If the gain is high, the output here is going to be high, maximum. Or use Zi as large Zi, then it will develop more of the voltage here, that will be transferred in the output. Or Zs should be minimum, it will drop less voltage, most of the voltage will appear across Zi, and virtually we get large output. Or increase Vs, we can write here V0. If we want V0 to be maximum, ZL should be high. Why? Because V0 is proportional to ZL. Or use high value of V1, use high value of gain. Why? Because these three are proportional to V0. Or ZO should be minimum, and if you keep ZO minimum, there will be less voltage drop here, most of the voltage will get in the output. Or use high value of the Zi, or use high value of Vs. Why? Because V1 is proportional to Vs and Zi, and inversely proportional to Zs. Use minimum value of Zs. When Zs has a minimum value, is going to drop less voltage. Now we can write for maximum V0, maximum V0 ZO and Zs should be minimum. For maximum V0, ZL should be high, gain should be high, V1 should be high, Vs should be high. Out of these, ZL, Zs, Vs, they have fixed values and they have no control of increasing V0. We cannot increase gain output by increasing any one, all, or any one out of these three, all the three. We cannot increase the output. We are left with the two choices, that is Zi and gain. We can increase the output by increasing A, and A is nothing but ratio of Z2 to over Z11, and it is feasible. Or use large value of Zi, or decrease value of ZO. By decreasing the value of ZO, the V0 can be increased. That's all. In the next video, we will solve 3 numerical examples. In the first numerical example, we'll see how the operational amplifier amplifies the small signal into large signal. In the second, we'll calculate the gain of operational amplifier when all the information, when all the factors are given. And in the third numerical, we will find out V0, V output, going to the main points. These are the two equations, equation 1, equation 2. We have derived it and we have explained it from equation 1 and equation 2. For maximum V naught, ZO and ZS should be minimum. ZO has inverse relation with the V naught. When ZO is minimum, V naught is going to increase. And Zs also, Zs is in inverse relation with V1. When Zs is minimum, V1 is going to increase and virtually V0 is going to increase. We can increase the V0 maximum output by increasing ZL. ZL should be high. ZL is proportional to V0. We can increase the V0 output by increasing gain. Why? Because it's proportional to V0. We can increase by increasing V1. This is V1, and by increasing Vs, we can increase, this is Vs. When we increase Vs, is going to increase V1. When V1 is going to increase, this is going to increase V0. But Vs, Zs, Zl have got fixed values and have no control. So to increase the gain, Zi or A should be high. It is feasible by increasing A, that is the ratio of Z2 to or Z11, the gain can be increased, or by decreasing ZO, the gain can be increased. Why? Because when we decrease Z0, it's going to drop less voltage and most of the voltage will appear in the output. That's all. Thank you very much.